Hello, students. Today we are talking about polynomial identities. And these identities are used mostly to factor um, and to factor polynomials, obviously, not quadratics. We've talked about factoring quadratics. Now we're going to be factoring things that have cubes in them. And um, basically, the best advice I can give you is you've got to have these memorized. So that's no fun, I know, but it is what it is. You are familiar already with the difference of squares. So if you have two perfect squares, it factors into a plus b, a minus b. And the next one is one that we talked about when we did quadratics, because when we completed the square, you needed to know this. But if you have a perfect square trinomial, that's what we call this, is a perfect square trinomial. Then you take the square root of your first term and the square root of your last term and multiply those by 2. This is how we got, when we were completing the square, that b equals 2 square root c. So that's kind of where that came from. Now, the difference of cubes and the sum of cubes are also just ones that you need to recognize. So you need to first recognize that numbers are cubes, and then you're going to split them apart in this way. So the best thing I can say is that you're going to see some examples of this, but you really just have to memorize. Memorize, memorize, memorize. I'm going to write it in 2 different colors. All right, so how can we prove? Where did these come from? And I think that that's part of what you can see. So let's see where these came from. And we're going to start by working this way. So how did we get from here to here? Well, let's start by multiplying these out. So I'm going to take my first term here and multiply it by everything in here. So we get a times a squared, which is a cubed, a times ab, which is a squared b, or it's negative because that's negative ab, and a times b squared, which is a b squared. Then we're going to do it the other way, and we're going to multiply b by everything over here. So we get b a times a squared, which is b a squared, and b times negative ab, which gives us negative ab squared, and then b times b squared, which is b cubed. So now, if you look at this should be negative. We have negative a squared b and positive a squared b. And we have positive ab squared and negative ab squared. So all of those cancel, and all we're left with is the a cubed and the b cubed. And you can do this with any of those identities, go from one way to the other. So now, that's how we get here. So now, how can we use polynomial identities to multiply? So here we have 2x squared plus y cubed. Well, you could write this out as 2x squared plus y cubed times 2x squared plus y cubed, and then FOIL. Or you can use the identity, which says that if you're squaring something, it is your a term is 2x squared, your b term is y cubed, and our formula is a squared plus 2ab plus b squared. So a squared is 4x to the 4th, b squared is y to the 6th. So we get 4x to the 4th plus y to the 6th out here. And then in the middle, we're going to have 2 times 4x to the 4th times y. Whoops, that is not right. It's just ab, not a squared b. So 2 times 2x squared times y cubed. So we get 4x to the 4th plus, and then this becomes 4x squared y cubed plus y to the 6th. And we didn't have to FOIL it, but you can if you want to. And we are not going to do this one because it's really stupid hard and doesn't make a whole lot of sense. So now we're just going to practice factoring. So going from the difference or sum of cubes and the difference of squares. So first of all, you have to kind of be able to recognize perfect squares and perfect cubes. So 9 and 25 are both perfect squares. So what we're going to say is this is a squared minus b squared. So what you need to do is figure out what your a and your b are. Well, a is the square root of this. So your square root of 9m to the fourth is going to be 3m squared. And then your square root of 25n to the sixth is going to be 5n cubed. So then from there, we write it as, we know, a minus b and a plus b. So we're going to have 3m squared minus 5n cubed and 3m squared plus 5n cubed. And we're done. So now we have 11 cubed minus 216. These are both cubes. So we've got a cubed minus b cubed. And the cube root of a cubed is, so our a is going to be x, and our b is going to be 6. Pretty sure. Yeah, is 6. So we know that this is a, let me use a different, we got a minus b times a squared plus ab plus b squared. And I got that just straight from here. A plus b, or whoops, here, this one, because it's a difference. So now we're going to have x minus 6 times x squared plus 6x plus 36. And we're done. So now here we have the sum of two cubes. So that's going to be a plus b times a squared minus ab plus b squared. Our a in this case is 11 and our b is 5. So we get 11 plus 5 times 11 squared minus 55 plus 5 squared. And you should know that this is 121. And there is your answer. So that's all I've got for you for this lesson. Super